Okay, I hope this is an AVI file. If having problems with recording. Alright, so summation wise, I'm going to show you or try to show you how loads can go down. Number 11 can go, loads applied to number 11 can go down 10. I'm going to establish a few playing grounds here, playing rules. OSHA states that grouting was done. Okay. Nowhere does it show that grouting was done after D1 and C2 was put tension before they moved on to 11. My hands are quite dirty. This is like the second time I made this video. Before they moved on to 11. The strings represent the post-tensioning. The line here represents the post-tensioning also. This is to scale. Now let's go ahead and I'll start talking and get this thing going here. Alright, so a little more or less excitement because it's the second video. Now this is to scale. Here's the other version of that scale. It's much larger. This is not the scale at this point right here is not the scale. I wanted to take some liberty and do this. This shows where the grout would be. But you can see how this would put this on a hinge itself, on a hinge point. All the loads transferring down here to this point. To this point. Not transferring fully. The loads are being concentrated on top of two shims. Transferring inside this girder, this diaphragm girder system, I call it, with the reinforcement. Okay. Looking at this, we see that, as I talked about before, some type of chaos mathematics. You've got the post-tensioning in 11 here. This has 4 bars in it. They are not post-tension yet, so don't think they are. I don't want you to think they are. They're just snug. They're not even on the schedule at this. They're on the schedule, but they're not at the same time. So this is 11 getting both of these done to the tune of 280 kips each. 280 kips each, right here and here, creating some type of zone, if you will, of zone there. C2 has been post-tension now. It comes across this canopy. C2 has resistance of the weight of the deck, the length of the total amount of 459 kips of like I said, of the load of the canopy, the cables, elongation, all this stuff. So the 459 kips, I don't know what that actually is doing to stop the canopy from deflecting downward. Let's move this little model out of the way. That one I need to play with longer. I don't want to mess it up. This one is the one I can mess up. It was measured off of, that one was measured, this one was measured off of that one, just tracing it. These go inside. They came off of the other ones. You can see the different colors to help you with scale. Jumping to the end of my video already, of the other one, watch what happens when I pivot from this point downwards. It kicks out. By default, it pushes. If it just goes down, if it can only stay in one position, it pivots from there, creating a crack in here. If it can only stay in one position, that's not how it happened. The bridge, when it was falling, the top of the canopy went over towards this way, pivoting that way just a minute. That's the outside of 12. Before the deck was getting pulled down, the deck part was being pulled down, then it had a reversal, and it came down to rest on the pier. That would be the outside of 12 and the top of the canopy. Let's move that out of the way. Let's take a look at this one real fast. This fits inside there. If we have the dipping in the deck here because of the scaffolding not resisting when they're post-tensioning, I'll show you that in a moment. I guess I should show you that now, and I'll put this here to remind me to use it again. So what I did was I put this cable here, if you will. That's D1. It's at 489 kips. It has to take the load of the deck, which is 1 foot plus, right, or whatever it comes out to with the taper. D1 is only next to the center of the deck, the center of the entire deck. D1 is straddling it, not. So this will be D1 down the center of the deck, if you will. D1s are here and D1 is here. D1 and D1, not ones. So D1's here and D1 is here. This is where the load points are going down the deck, if you will. This would be number 9, 10 node, a load point. Resisted by the post-tension stirrups and here, the bars, and the concrete. The stirrups and the bars and that's about the size of that. And then we have D1 across for 489 kips total. But the loads can't transfer the D1 because why? The transverse cables are not post tension yet. So they can't get the loads over there. And I've got another video planned for that for you guys to show that. And I don't know if I'll do it today or later. I will load it though. Gosh, I hope this video doesn't make me do this again. It's loading under the wrong format, and yet I've got to configure the load AVI. So what I did was I cut this is to scale, and all I did was cut out a section here, as you can see this gap. I put the cable there, so the cable would be resisting some downward force, but it's going to be limited because the ductwork is not grouted. So it's going to still be able to flex. We'll still be able to flex. Theoretically, it should be able to flex pretty good with just hollow tubes, right? It's with the 489 kips total. So I want you to look at two things here. We're going to look at this gap. Now they had scaffolding here, but nowhere did I find scaffolding. Let me check my camera here. Okay, nowhere did I find scaffolding that was extra reinforced, if you will, right at this nodal area, or at 9, or down here at 9 and 10 going to the ground. I showed that in the other video. So the scaffolding is just normal scaffolding to hold up the formwork, I think. Not designed to take the loads when this redirect of loads down 10. I mean, maybe as simple as that they didn't realize that, like I said in previous videos, that they didn't say that they didn't realize the loads were going down 10 when they did this number 11. So I'm going to pull on this, watch this close up. Let me make sure I can see it. Yep, okay, good. So I'm going to use my hand as a little clamp. Sorry about that. My tape is slipping on the other end. I just got to tape down. Let's try the other one now. So do you see what happens there? Is that it closes, it's sliding on the floor too. But it's, well, that's proving a point too, right? It was sliding on the floor. It's showing you what's happening there. So that it has that torque effect. So because it's created in this angle. Now let me go zoom out. Let me zoom out and continue that part of what I'm stating. Oops, going the wrong direction. So I think it's as simple as that. The torque created with this, whatever it is, 38 degrees, whatever it might be, I forget, created a downward force down 10 that did not have any scaffolding to the properly supported scaffolding. Scaffolding could deflect even. It doesn't even have to go into the ground. It can deflect up here to start creating this problem. These could just buckle a little bit. The scaffolding could have some deflection in it. If you look at the scaffolding again, you'll see nothing special, and yet they're going to load 560,000 pounds of force into this member. I don't know how much of that is actually going to go back to that nodal area there, and how much of it went down 10. So I theorized it went down. The amount that went down 10 created a depression in the soil, and this created a sagging in the deck. That when the CEI looked at it days later, 6 days later, talking about these cracks, by then it already rebounded back. So look what I'm doing here. I'm taking liberty, but there's 4 post-tension bars in here. That would also limit the amount that it would separate. But I'm taking some liberty here and tainting the waters a bit, but I'm showing you the bounce back. That if you look at it 6 days later and start evaluating it, you're going to see tension opening in the cracks. Open cracks, or not compressive. So it's going to give you a false identification of it. And that's what I assumed too when he said there was tension in here, tension cracks, per the CEI. That I kept having to do that tension in here. I had this end down here having to camber the deck up. And I just couldn't create that. But what I could create was forces going down 10. And it shows that in the failure where it broke here and here. So how am I not getting, how am I getting forces? How are we getting at that? So, well, because that was a misinterpretation. I showed that in a previous video where the reinforcement is actually this direction. And his description of the cracks make them seem like they're going this direction, which is parallel with the deck, which would be parallel with the deck deflecting. And again, we get the deflection easily, I think, by scaffolding. The load's coming down here, pushing this 10 down, pushing the canopy down, causing a deflection there, no longer changing the profile of it. And then along comes the post-tension C4 at the same kips, or whatever the kips require, rather, for C4. But they have a different profile now. They got C2 at one amount of force being applied to it. And then this took some of that force and redirected it here instead of the ends. So you no longer have, your profile is no longer compressing at the ends. It's now compressing with a dip at the middle. So it's compressing here, which again helps to send your forces down 10. Again, my whole thing is about the loads went down 10, never making it out to there. They didn't go, there's a symmetry, there's an equilibrium problem here. It could be something as simple as this measurement not being perfect also. These aren't parallel. And this would also create the deflection, the loads not going down 10. But again, Denny Pate, I think, designed this where all the loads were supposed to be handled in the deck. But I think failure might have already started happening when they did this. This system here, D1, was already being loaded incorrectly without the transverse bars. And when they loaded the transverse bars, here's D1, when you add D2, D6 and all that, these guys are already past their 70%, which I think Denny Pate, or is it Erica, set it up, and Denny Pate signed it, was the ultimate one to sign off on the plans. But so this created this profile. The zone is no longer equal as the column is coming down. Oh, another video. Maybe I'll give you a quick shot of it here. Quick shot. So D1. Quick shot. All right. Here's the 910 load, 910 node. And the forces are going down. It does not have these transverse cables, they're not in play yet. They have not been post-tension yet. So now it's just lying there having nothing to do. They're cables, they're not rods, so they don't even participate with resistance. You know, you'd have to really elongate them for that. So the load on this is already, missing this more than likely. And it's already they're trying to recapture it once they do D2 and D2. D2 now has, instead of just normally doing D2, D2 is now being stressed and pulled by D1 because D1 is experiencing some forces off of whatever this point load is. So don't think of the whole length of it like the OSHA report. Looking from a top view down, this would be 910 node down, right? Well, let me just do this. Let me run 45 off of each corner, and you can radiate it. You can radiate the base of it, if you will, that, distributing the load in that capacity, but only here, going the length of the deck down to number 12. So here's 12 down here. Only here is D1. Does it ever make it out to D1s? Does it ever make it out to D1s? And then we have the transverse cables. Finally, when they come in, it's all after the fact. It's all after the fact. They're not helping out. Now, we just need to know, did they calculate how much they calculated the load would go down 910. If we can't find any calculations on anywhere that they had no loads going down 910 when they did 11, then we know that's a simple problem right there. But if they did calculate loads going down 910, how much and why didn't they? How did they predict that it would transfer the loads that came down 910? How did they predict it would transfer still? Well, after the fact, start doing D2 through D6, and then the transverse cables. It's got a moment. It's got to try to lift up now. It's too late. It's cupping from underneath, trying to lift it up, sort of like what they did in number back here, trying to recapture it after the fact. Cat's already out the bag. The loads are already down below it. Now you're trying to pull it back up. You're creating a profile. A profile that theoretically didn't work. Obviously, it failed.